welcome to GIS. So today we are going to delineating groundwater potential zone mapping using GIS and remote sensing. So groundwater potential zones are prepared by using various multicriteria factors using GIS and remote sensing. This is a process that uses geospatial data to identify areas that are likely to have groundwater, availability of groundwater. This information can help with selecting locations for these locations. So there are certain steps. First, collect data from global and national data providers, for example, remote sensing data for land use land cover classifications, and downloading remote sensing data, for example, digital elevation model to produce a slope map of the study area. So analyze, that means analyzing slope, for example, in ArcGIS. So then collect and identify factors, then assign weights using this string of significance. Then after that, we are going to combine using multicriteria analysis or overlay analysis in ArcGIS. So the 1 to 9 scale of parameter significance, 1 means equal significance. If we give compare one parameter to other parameter, if we give 1, we have the influences equal significance, 3 medium significance, 5 strong significance, 7 very strong significance, 9 maximum significance, and others. This is a provide comparison method that we are going to discuss on the next automatic Excel sheets. This is normal principal gradient vector. This the combination of all the sum of this percent becomes 100. So that means in order to influence certain factors, in our case, we have 5 factors: drainage density, rainfall, slopes, land cover, and elevation are the main parameters for in this case. So we are going to, I will show you how to combine these factors. By the way, I will not go through the detailed processes in order to prepare, for example, land use land cover, rainfall, and others, because I have made several videos on this regard, how to prepare these controlling factors or thematic layers or thematic maps for multi-criteria analysis or weighted overlay analysis. So you can refer this video in the GIS YouTube channel. You can explore. So that now we have ROA, means region of interest. That is study area. This extract means this is digital elevation model, DM. So we have rainfall, we have land use land cover. So first, let us derive this stream density. In the case of stream density, we are going to spatial analyze first, then density. Then in this category, there are 3 options. In our case, it's, since streams are lines, vectors, we are going to perform this line density, double click on line density. So select this one streams. So select other things as it is and click OK. So line density is calculating, which gives rise to in drainage density. Okay, great. This is drainage density. So this is now this is the raster layer. We are going to extract or clip. Then go to spatial analysis, go to extraction, go to extract by mask, double click on extract by mask. Then this range density. So input raster or feature mask data must be region of interest or study area. Then click OK. For that, output raster means the file name in which you are going to place on a folder. In my case, let me accept the default folder and go to OK. So this is drainage density. Let me rename as drainage density. Yes. Drainage density. So let me remove this one because I have already used. So let me remove. So we have drainage density, we have DM, that means elevation. Let us rename this as elevation. Elevation. Yes. 1, 2, 3, 4. So let me uncheck these streams because I have already used, and let me uncheck also region of interest. So let us let us derive this slope from elevation. So go to spatial analysis. So go to surface, then go to slope, then go to select this elevation. Yes. So select output measurements. Two options only available: degree and percent rise. In my case, let me select percent rise because I want slopes in percent. So select percent rise. Just click OK. Now slope is deriving, calculating. Let us wait the results. The slope is in percent. Slope in percent has been calculated. So let me reclassify this slope. So go to again in spatial analysis tools. Go to spatial analysis tools. Yes. Go to spatial analysis tools. Then go to reclass. Go to reclassify. Yes. Select the raster as this slope. The generated slope. So reclass field is value. Then classify by 4 by 5. For example. Okay. Okay. The classification system has been processing. Let us wait the results. The reclassified slope. That is 120 degrees. So let us remove this one. So let us rename this as slope. Okay. So slope. So drainage density. Yes. So let us classify this drainage density the same as with slope. Yes. Classify. This becomes 5. 5. Okay, great. Okay, great. Okay, great. Density. Renaming. So slope, we have slope also. So let me remove this one, the former drainage density. Let me reclassify this one as the same as with others. This elevation, select elevation, classify, and to 5. Yes, yes, yes. So let me rename this as elevation and let me remove this the original one because so rainfall remains. Let me reclassify rainfall also. Yes, rainfall value classify. Yes, 5. Great. Okay. Now let us rename this one as rainfall. Okay, great. And let me remove this one. Okay, great. So land with land cover cannot be reclassified. It is a discrete file, so we will keep this one. So all have been reclassified successfully. Now let us go to this Excel sheet. This is AHP, analytical hierarchical process, and means number of criteria. In our case, 5. Okay, let me. Objective is application of the GIS and multi-criteria decision analytical hierarchy process AHP in the groundwater mapping. This Excel is automatic hierarchical process developed for computing multicriteria analysis or weighted overlay, so that you can use this for multicriteria analysis decision making processes in ArcGIS. So that this is one example. So let me write this one rainfall. Yes. So slope. Yes. So drainage density. Drainage density. So 5 factors. Drainage density. Elevation, and the last one is land use land cover. So we will make comparisons. 21.6, 31, 14, 15. The sum of this will be 100%. But our objective is which one of the five criteria gets the highest value, and in what basis we can going to calculate such kinds, or going to give weight for this factors, for these factors. So this is we can use various methods. The first one is expert judgments, discussing with the experts, DS researchers, and the second one is extracting from previous studies, journals, and researches. So that by combining this, we are judging, giving the weights, and go to ArcGIS and combine these factors in order to produce the final output, that is groundwater mapping, with the help of ArcGIS. So that now let us go to this one. Yes, comparison, that is rainfall against, yes, rainfall or slope. So let me select A means rainfall, so A 3, for example. 3 means more important. Rainfall or drainage density. Okay, let us select this one. Okay, rainfall or elevation. So rainfall. Yes. So rainfall or land cover. Yes. Let's make this one as, yes. Create a slope or drainage density. This is slope. Great. You can change these variables based on this equal importance, very strong importance, or whatever. So based on this, you can change. This is just for the, this is exercise purpose. Yes. Example, to make this one, yeah, equal importance. Yes. So this is the final RGM means the final weights. The sum of these weights will be 100, and when we return back to summary, this weight is also available, this one. So let us see, the sum of this is 100. Let us return back to ArcGIS. Now let us combine all these five factors based on the weights we have got from these Excel sheets. So go to spatial analytics, then go to overlay. Yes, go to overlay, then go to weight overlay. Select this one. The first one is rainfall. Okay, great. The second one is elevation. Select this one. Okay, great. The third one is also drainage density. Okay, great. The fourth one is also a slope, and the final one is also, yes. Click on this plus sign and select the rasters. The final one is also land cover. So rasters influence field value, scale value, no problem. So for example, rainfall 26.7. Let us make it doesn't accept decimal, so let us round it as 27. Yes. And the second one is 28, 22.8, 23. And the same is true for drainage density, 23. Yes. And the fourth one, which is elevation, is 20. Yes. 20. And the last one, land cover, is 7. Yes. So after this, output raster means the place where you want to save your output. For example, I can select the folder that I want to put my results. but let me accept the default and click OK. Now weather overlay is running. The final result will be generated based on these four rasters. Great. So let us uncheck all others. Yes. This is groundwater potential zones. Yes. This is very low availability of groundwater. And the second one is low. The second one means low. Yes. You can rename just this one. This is moderately available. This one is high. This one is very high. Yes, apply. Okay. We can calculate this one. For example, what is the cell value for this one? 500 meters resolution. You can calculate this one. Let us make some amendments on symbology. Yes, symbology. Let us make some amendments. For example, yes, groundwater potential zones. Yes, let us select, for example, this one, not this one. Okay, this one. Yes, yes. Okay, great. So in order to make the final map of produce a final map, let us make a map layout by 2 meters. Just click this one, layout view, or just view, layout view. Okay, great. You can zoom in and zoom out. Go to insert, go to legend, next, finish. Let us make to this one. Yes. Okay. Yes. What are other map elements? Insert, north arrow. Let me select this one. You can use what you have, what is a favorite one, but this is an example. Okay. What left? Legend, northern scale bar. Let me select this one. Yes. Yes. This one. Properties. You can change the miles into kilometers or as it is, but how to change the units can be found here. 5 miles, for example, change into kilometers. Then the label becomes okay. Apply. Agreed. Yes. What left is insert. Legend line. Okay. Great. Grid is remaining the very important one. New grid. Next. Finish. Apply. Let us see. Okay. Let us make some amendments. Lines. Do not show lines. Okay. Apply. Yes. Properties. For example, intervals. Yes. Apply. Okay, great. Properties. Yes. Labels. Left and right becomes vertical. This becomes Times New Roman. This size becomes tall and becomes bold and becomes apply. Okay. Very simple. Okay. So what remains is degree, minutes, and seconds. Insert. Net line. Place around elements. Okay. Okay, great. So this is Next line. Okay, great. Okay, great. File, export, map. Yes. Let me back this one. Yes. Groundwater. Groundwater potential zone. Map of groundwater potential zones here. As image is exporting. Let's with the results. This is how GIS helps to define. Yes. Yes, this is very low groundwater in the southern and in the uh, western part, central and the northern part, high to very high and moderate. Yes, so some interventions will be recommended based on these maps. So the map is used to scientific recommendations. Okay, so this is an example. Make sure that all the parameters should be the same resolution, the same projection, and downloaded and acquired from reliable sources and validated correctly according to experts' judgments, researchers, and against all articles or journals, and in reality, in respect with study areas. This should be applied in your research projects or in your researches or projects. So this is what we have today. Thank you for watching.